want to choose the main laser welder for science fabrication. Now we're going to show you how to set up this machine and how to operate. Okay, first you will see the whole system like this. This is the welder, this is the table, the foot pedal, the monitor, the CCD, and the laser head, the illumination, and this is the operation panel in emergency stop and key switch, and the water chiller. Another version of water chiller like this, of better quality and higher cooling capacity. Let's start. First of all, we connect the air switch, and then we turn the key switch. Oh, sorry. Okay, first of all, we need to turn on the water chiller for 1 or 2 minutes until the water temperature reaches the target value you set. Normally we set 25 degrees in autumn and in spring, or 30 degrees in summer. Okay, then we turn the laser power on. This is the welcoming page. Then you need to press this button and wait for the charging to finish. Waiting, let's see how to connect the water and the power supply. Well, as you see, there are 2 water pipes. One come in and one an inlet and one outlet. They have to connect it with the water chiller, so that the water forms a circulation. If the water chiller, if water comes out from this pipe, then it should connect with the inlet of the laser. And another pipe should be connected with the output of the laser, the water chiller. 这个怎么 the power supply for the chiller, and this is the power supply for the laser. It's 220 volts. We didn't connect the grounding wire, but we suggested to do that when you're working. Okay, now the charging has already finished, so it is ready to work. Okay. You will see a red crosshair on the monitor, and you put your material towards the locating pin and try to pull it towards your body and give some pressure on the material so that the side coil and the front plate can touch each other very firmly. Okay, now like this. Now you can see the line to be welded is overlapped with the red crosshair. Okay, the position is ready. Now we make sure the parameter setting is correct. As you can see, this is 1 mm stainless steel, so I would suggest parameter setting like this. 80 amper frequency at 20 and the pulse width at 2.0 hertz. ms. The current, it always decided by the thickness of the material. If the thickness is bigger than 1 mm, then you may set like 90 or 95 or even 100. The frequency decides the speed of the laser shooting. It means 20 spots can be generated within 1 second. so it decides the speed. Then the pulse width decides it means how long a single spot stay on the material. So if the material is thicker, you need to set it higher. But normally we set it at 2. Sometimes for galvanized sheet we set 3 or 4. Okay, let's go back to the table. Okay, now I show you how to. Okay, one more thing is that there is you can adjust the position of the seam you're going to weld. See, when I pull, what I need is like this, perfectly match. Okay, now here we go. For stainless steel, we don't have to weld the full line. We just pick a few important spots or corners to form the whole structure of your letters or signs. If you think this is too slow, when you are more professional, then you can set the frequency higher. Wait a minute. Okay, now I set frequency at 40. Try to compare. Okay, for some letters like this, with a high wall, when you put your letter in front of the locating rod, when laser comes from the top, it will probably blocked by the wall. So in this situation, we will turn the letter a little bit so that the laser can go straight into the corner, like this. Okay, I try again. If this not working because of the blocking of the wall, you turn the letter into this angle so that the laser shoots onto the material. Normally the surface won't get burned or yellow or brown dots on the surface. If you find some burnt spot like this, then it means you set the current too much higher or the pulse width a little bit higher. Okay, this is more clear for you to check.